And welcome to the next series. Today we are going to take a look at how data moves through the protocol stacks from one device to the other device. Let's begin by saying this computer would want to transfer data to this other computer. And as you can see, we have on the protocol stack, we have from the application layer down to the physical layer. We're using the OSI model. And this one, this other computer would have the same layers in its, protocol stack. So what will happen is that the user in this, the user of this device would simply go into his, browser or any other application that can be used to send message such as WhatsApp, email, all those kind of applications at the application layer. He would form the message, and then after forming the message in the application layer, especially using a WhatsApp message, typing hello, you've already created the data. That's using the application to create the data. So this data would be sent down to the presentation layer. The presentation layer would have to format the data into the appropriate format, into appropriate extensions. If it is a file, a text file .txt, if it's a PDF file .pdf, image.jpg or the .jpeg, all those kind of things. That would happen at the presentation layer. And also mind you, the presentation layer handles data, doesn't convert data into bytes. But when the data is pushed down to the session layer would now create a session. When we say to create a session, what it will do is that it would add breakpoint in the data so that in case the transmission fails along the line, you can resume it from a previous checkpoint. That is what the session layer does. For instance, when you are doing a download from the internet, you're able to pause the download because of this behavior. You would pause it, that means you put a checkpoint. Then whatever you want to do, you do it, then you come back later and then you resume the download. That's what the session layer would do for you. And then after it has done all that kind of things and putting the checkpoints in the data, it moves the data down to the transport layer. So what does the transport layer do? The transport layer would add a header. That's layer 4 header. What does this do? This would have to break down the data into segments. Assuming the data you are going to send is more than the MTU or more than the window size, we would explain that in subsequent videos. The segment layer would break down the data and add layer 4 header. Inside the layer 4 header are sequence numbers that will help to track the data at the receiving end. And also port numbers are added here to identify the specific application that will receive the data. For instance, at the receiving end, the user might have installed WhatsApp, Facebook, Outlook. When the message finally gets to the user, which of this application would receive the data, would display the message? It is at this layer that a header would be added, and a port number will be added, and that port number would specifically identify the application on the receiving device that is going to receive the data. So when that is done, what happens next is the data is further pushed down to the network layer. At the network layer, it identifies the destination network. Mind you, this identifies the destination network, not the receiving device, but the destination network. So it will add IP of the destination network, of the destination device, and then an IP of the what? Source device. Okay. Device A would say my IP is 192.168.1.1. I'm sending it, and this one is, and so it will be embedded. That IP will be embedded into the head, into this header, into the layer 3 header, and the destination IP would also be embedded into the layer 3 header as well. So from there, after all of that, it moves the data down to the data link layer. Just as the transport network, the data link layer also add a header and add a trailer. So basically, this is to identify the node, the specific device that is going to receive this data. We say earlier on that every system has two ways of identifying. You have two ways to identify the system. You can identify the system either by using the MAC address or by using the IP address. But at the data link layer, we use the MAC addresses. That is what identifies specifically which system is going to receive this data. And at the data link layer, that is what it does. It will encapsulate the layer 3, layer 4, including the data with a layer 2 header, and then an FCS or RCS or CRC. So this FCS or CRC is used to check for errors when you eventually transmit the data onto the cable to the other end. How does it do it? It does it using a modulus arithmetic calculations. For instance, it will divide the data by some specific number and keep the remainder in the FCS or CRC. Okay. So let's go on. And at this data link layer, this whole thing is this whole PDU is called a frame. And you can see at the network layer, when it was at the network layer, it was called a packet. And then at the transport layer, it was called a segment. That's why you would see that I have segment, packet. So this is called a frame. And this is the specific structure of a frame. So from here, this data would be pushed onto the physical link layer and be transmitted into be transformed into what? Zeros and ones. That's electrical signals. That will be sent via the cable to the other physical layer. When the other physical layer receives this, then the other device receives this signals. What it does is to reconstruct, to push this bit to the data link layer, and then the data link layer will reconstruct the frame out of this sequence of ones and zeros. So it is able to do that because there are some specific sequence that that the receiving device will study, and it know, oh, this part is the layer, the L2 header, and then it encapsulates the rest of the data, and then also check the CFC. What will it do? It will do the same calculation the sending device has done, and if the value it got is the same thing, matches the FCS it received from the sending device, then the data is deemed to be error-free, else the data is errored and will be dropped. So you can see the receiving device, the data is first sent to the physical layer, and it is moving up the protocol stack. So it's two ways. The sending device starts at the application layer and send down the data down to the physical layer before it is able to transmit it, because it is only at the physical layer that there is a physical connection between the two devices. So when this one receives it, will receive it at the physical layer and begin to undo what the sending device has done. Before I forget, let me mention that the process of the data moving from the application layer down to the physical layer, at each stage, let's start at layer 4, at each stage a header is added. This process is called encapsulation. So when the receiving device gets the data at its physical layer, it does the reverse, decapsulation. It will break down the headers, because the user doesn't really need to know, doesn't really need to receive the frame, or doesn't really need to know the IP address. You don't know the IP. Some people don't know the IP addresses they are actually their machines are using. So it will break down the layer 2 header and also remove, after checking the error and see that this data is error free, it will remove the trailer and send the rest of the data to the network layer. So the network layer will do the same thing, will decapsulate this whole packet. What it does is to check, which IP is this which IP is the packet going to? How do I route it to the? Already it is at the destination, so it will check that if the IP is its own, fine. If it is not its own, it will drop the packet. Okay, then it will break the layer 3 header and move the rest of the data to the transport layer. The same thing with the transport layer check. The transport layer check the layer 4 header, which we say it contains the segment number, the sequence numbers, and then the port numbers, the most important things. It will check the sequence number and group all segments with the same sequence layer and send it upwards, so that you don't receive the data in you don't receive disordered data. Okay, so when it does that, it will simple break or remove the layer 4 header. Now it is only the data user A has sent that is left, so it will move down that to the session layer. At the session layer, the connection has now happened. The session layer of device A would acknowledge the session layer of device B, and then the session is created, provided it is we are using some kind of protocol like TCP. But then let's go on. As we go on further into the course, you would understand what TCP, UDP are. So this will now move the rest of the data to the presentation layer. The presentation layer will convert the data into the appropriate format, if it's picture.jpg, .jpeg, .mp4, in that order, and then move it to the application layer. The application layer would if it is a WhatsApp application that this person has sent the data from, it will receive on the WhatsApp. It will be received on the WhatsApp in the receiving device. And if it is also a browser, you would receive the HTML file on the browser, and then eventually you get your data. So folks, this is how data is transmitted from one device to another device. This is just